Welcome to the GeoMethod channel. Today we are solving another interesting geometry problem. Here is today's challenge. Can you calculate the perimeter of the green polygon? Take a moment to study the figure. Then let us uncover the key geometric ideas that make the solution click. Meet the green polygon with corners A, B, C, D, E, F, G, and H. Every side runs only left to right or up and down, and we need to find the total distance once around its boundary. Every corner of the green polygon IBCDEF segment GH is a right angle. That single structural fact is the key because it forces each edge to be perfectly horizontal or perfectly vertical with nothing slanted. Because of those right angles, each side is parallel to one of the axes. So the whole boundary is built from just two kinds of edge, horizontal ones and vertical ones. Let us count as we walk around. 4 edges stand upright: segment AB, segment CD, segment EF, and segment GH, and 4 edges lie flat: segment BC, segment DE, segment FG, and segment HA. That balance will let us handle each direction on its own. That lets us split the perimeter into two independent sums: H, the total length of all horizontal edges, plus V, the total length of all vertical edges. We will find each sum separately and add them at the end. We are handed only 3 lengths: 5 down the right side from A to B, 3 across the bottom from B to C, and 4 across the inner edge from F to G. Everything else we must deduce. Start with the vertical edges. Walking around the boundary, only one of them ever points down. The right edge from A to B, worth 5 units. Every other vertical edge points up. Our first insight is this: a closed path balances opposite directions. Apply that rule. The upward edges are C to D, E to F, and G to H. And together they must add back exactly the 5 we went down. We never needed their individual lengths. So the vertical edges give 5 going down plus 5 coming back up, a total of 10. The first half of our perimeter is settled. Now turn to the horizontal edges and hunt for the ones pointing left. Along the bottom, the edge from B to C runs left by 3 units. That is our first left run. But watch the edge from D across to E. It points the wrong way to the right. This little notch is the whole trick of the problem, and we will have to respect it in a moment. Continue around. In the left middle, the edge from F to G runs left by 4 units. Checking the rest of the boundary, that is the second and last edge that points left. Only the 3 and the 4 point left. So the total leftward travel is 3 plus 4, which is 7. Keep that number in mind for the closure step. A second insight now finishes the structure. The same closure rule controls horizontal travel. The 2 rightward edges, segment DE and segment HA together, must equal the 2 leftward edges, segment BC and segment FG, a total of 7. This does not say segment HA alone is 7. So the horizontal edges give 7 going left plus 7 coming back right, a total of 14. Now we have both halves, but let us see exactly why the notch matters. To see the danger, let us build the smallest rectangle that contains the shape. Mark a new corner point X at the bottom left, then draw the segment from C straight across to X, and the segment from G straight down to X. The polygon now sits neatly inside rectangle ABXH. Vertically, the polygon spans the rectangle from wall to wall with no gaps. So its vertical edges total exactly twice the height 2 times 5, which is 10. That agrees with what we already found. Horizontally, the notch adds extra left-right travel. That is why we sum the actual left runs 3 and 4 rather than infer one width from the box. Bring the two halves together, 10 from all the vertical edges plus 14 from all the horizontal edges. So the answer is 24. That completes the solution. A good geometry problem often has more than one beautiful solution. If you see a genuinely different construction, a high-level idea that leads to another solution, or a thoughtful adaptation of an existing method, share it in the comments. Even a rough idea is welcome. A sketch of the key move is enough. We greatly appreciate these contributions. With your permission, we may feature the approach in a future Viewer Solutions episode and acknowledge you by name or channel handle. Thanks for exploring geometry with GeoMethod.